Good day, everyone. Today we will discuss about logarithmic functions. Logarithms comes from the Greek word logos and arithmes. Logos means logical, proportional reasoning. Arithmes means measure or number. Logarithms were a calculation tool which greatly reduced the amount of time needed to multiply large numbers. Logarithms are used to measure spacing in guitar frets, intensity of earthquakes, mineral hardness, sound intensity, and many more applications. And today, we have these learning objectives. At the end of this lesson, you will be able to define logarithmic function, diagnose logarithmic function, logarithmic equation, and logarithmic inequality. Investigate the behavior of the graphs of logarithmic functions with its properties. Now let's define logarithmic function. A logarithm base b of a positive number x satisfies the following definition. For x is greater than 0, b is greater than 0, b must not be equal to 1. This can be written in the form y equals to log with base b of x is equivalent to b to the power of y equals to x. Now let's talk about common logarithms. Common logarithms is a logarithm base 10. We write log with base 10 of x simply as log of x of a positive number x satisfies the following definition. For x is greater than 0, b is greater than 0, b must not be equal to 1. So we have here y equals to log of x is equivalent to 10 to the power of y equals to x. Now let's talk about natural logarithmic function. The function defined by f of x equals to log with base e of x is equal to ln of x, wherein our x here must be greater than 0, is called natural logarithmic function. Now I will show you some examples of logarithmic functions. Function f, which is equal to log with base 4 of x minus 1. Function g, which is equal to ln of x, or what we considered as natural logarithmic function. Function h, which is equal to 2 plus log of x, wherein this is considered as common logarithms. Because there is no base written here, so it has been assumed that our base here equals to 10. Now I will show you the relationship of exponential and logarithmic functions. Exponential function x equals to b to the power of y, and its inverse is called logarithmic function. F inverse of x equals to log with base b of x. Here, we found out that exponential functions were really one-to-one functions with a special property that its inverse are also functions. Logarithmic and exponential function are inverse functions. Now let's convert logarithmic form to exponential form. For example, we have log with base 4 of 1 over 16 equals to negative 2. To do that, we need to follow this formula in converting logarithmic to exponential. After that, we need to rewrite. And we need to find out the value of b, the value of x, and the value of y. After finding out the value of b, x, and y, here we found out that our base equals to 4, the exponent equals to negative 2, and we have an x equals to 1 over 16. After that, we need to substitute for b, y, and x in the exponential equation, which is b to the power of y equals to x. So therefore, we have here 4 to the power of negative 2 equals to 1 over 16. To check, we have here 4 to the power of negative 2 is just equal to 1/4 square, which is just equal to 1 over 4 square, which is equal to 1 over 16. So we got the correct answer. Now let's proceed on converting exponential to logarithmic form. So for example, we have here 5 cubed equals to 125. So we need to use this formula. And we need to rewrite, find the value of b, the y, and the x. And in this case, we have here our base, which is equal to 5, our y, which is equal to 3, our x, which is equal to 125. After that, we need to substitute for b, y, and x in the logarithmic equation. Log with base b of x equals to y. So we have log with base 5 of 125 equals to 3. So now, I will show you some examples of converting logarithmic to exponential or exponential to logarithmic. Let's start with exponential equation. So let's just say we have here 2 cubed equals to 8. So this can be written as log with base 2 of 8 equals to 3. Another is we have 3 to the power of 4 equals to 81. So this can be written as log with base 3 of 81 equals to 4. Now let's try logarithmic to exponential. Let's just say we have log with base 9 of 3 equals to 1/2. So to write that one, we have 9 to the power of 1/2 equals to 3. Another, we have log with base e of n equals to m. So we have here e to the power of m equals to n. Another is we have log with log of x minus 1 equals to y. So we have here 10 to the power of y equals to x minus 1. Now let's discuss logarithmic properties. In property number 1, it has been stated here that if you have an x value equals to 1, kahit na anong value ng base na meron tayo dito, this is always equals to 0 because b to the power of 0 is equal to 1. For example, we have log with base square root of 5 of 1. This is always equal to 0. Property number 2 states that if you'll have log with base b of b equals to 1. So kung na-observe natin na yung x at saka yung base natin ay equal yan, magiging equal lang daw yan sa 1 because b to the power of 1 equals to b. So for example, we have log with base square root of 3 equals to 1. Na-observe natin na equal yung dalawa, so we have here equals to 1. And in property number 3, if you have log with base b of b to the power of x is just equal to x because b to the power of log with base b of x equals to x. So we have here, this is an inverse property. So we have log with base b, which is 10. Then we have here 10 to the power of 5, which is our x. We notice that here, the base and the base of this x here are just the same. So we have here as our answer, which is equal to 5. If log with base b of x equals to log with base b of y, then x equals to y. This is by 1-to-1 property. For example, we have log with base 3 of x equals to log with base 3 of 5. We notice that these are logarithms. And aside from that, we notice that they have the same base. So therefore, by 1-to-1 property, x equals to 5. Now let's proceed on classifying or diagnosing logarithmic functions, equations, and inequalities. Logarithmic function is the function of the form y equals to log with base b of x, where our x here is greater than 0, our base is greater than 0, and the base here must not be equal to 1. So for example, we have function f, which is equal to log with base 3 of x minus 4. Next is we will proceed with logarithmic equation. It is an equation involving logarithms. It can be solved for all x values that satisfy the equation. For example, we have log with base 3 of x plus 3 equals to 2. In logarithmic inequality, it is just an inequality involving logarithms. It can be solved for all x values that satisfy the inequality. So for example, we have log with base 2 of x minus 5 greater than or equal to 4. And now let's identify the following. In this case, what have we noticed? This is considered as logarithmic equation. It is because it involves logarithm, and the symbol that has been used here is equal sign. So therefore, this is logarithmic equation. Next we have here, it is a function as well as it involves logarithmic expression. So therefore, this is considered as logarithmic function. Here we have logarithmic expression and it uses an inequality symbol. So therefore, this is considered as logarithmic inequality. Here, we have here as nag-i-involve siya ng logarithmic expression at gumagamit siya ng equal sign. So therefore, this is logarithmic equation. Okay, now let's proceed on graphing logarithmic functions. In graphing logarithmic functions, we need to familiarize the term for the domain, range, intercepts, and asymptote. For the domain, these are just the values of x. For the range we have here, these are just the set of values of y. For the intercepts, we have x-intercept and y-intercept. If the points lie on the x-axis when y equals to 0, that's considered as x-intercept. But whenever the point lies on y-axis when x equals to 0, so that's considered as y-intercept. Now in asymptote is the line that a graph keeps approaching but never touches it. Asymptotes can be vertical, horizontal, or oblique. Now I will show you some procedures in constructing the logarithmic graphs. Step number 1, find the domain and range. Step number 2, solve the x and y intercepts, if there is any. Step number 3, find the asymptotes. Step number 4, construct the table of values and plot the points. Step number 5, sketch the graph using smooth curve to complete the graph between and beyond vertical asymptotes. Now, I will visualize to you the relationship of logarithmic and exponential functions using graphs. We notice here, look, that they are symmetric. This is what we consider as the blue one is the exponential, the red one is the logarithmic. We notice that the graph is symmetric at line y equals to x. And here, this is 1-to-1. This is also 1-to-1. And since it is 1-to-1, it has its inverse. And we notice that their inverse is also a function. And here, we have here increasing We have here also an increasing na graph. Both are increasing, and we notice that they are symmetric at line y equals to x, this broken line. Now, I will let you visualize the graphs of the form function f, which is equal to log with base b of x, wherein our b here is greater than 1. So for our domain, pag solve ng domain ito, we notice from the definition that our x is greater than 0. So our domain here is 0 to positive infinity. There would be no negative values of x. For the range, we have here the set of all real numbers, because any values of x that has been substituted here from 0 to positive infinity, then the values of y would be positive, negative, or 0, or just the set of all real numbers. For the intercept, what we need to do here is just we let y equals to 0. If y equals to 0, then the specific value of x that will satisfy to that statement is just x equals to 1. So we have here 1, 0. For the y-intercept, we need to let x equals to 0. Take note from the definition, hindi pwede na si x ay mag-i-equal sa 0 because it will make the function undefined. So therefore, we don't have y-intercept. We notice that the graph is an increasing graph, and for our vertical asymptote, we have here y-axis or x equals to 0. And it is continuous. Now I want you to observe the values of the graph, or the behavior of the graph, as the values of b increases, or as the value of b becomes larger. What happens? It becomes closer to the x-axis. Observe? Diba? Okay. Now let's have another function. Let's just say we have log with base b of x. In this case, our base is between 0 and 1. So for our domain, we have 0 to positive infinity based on the definition. For our range, any values of x here within this domain, ang mariresult lang niya is 0, positive values, negative values, or just the set of all real numbers. For our intercept, what we need to do, we let y equals to 0. If y equals to 0, the only value of x that will satisfy that is x equals to 1. So we have here 1, 0. And we notice from the graph, this is decreasing graph. And for our vertical asymptote, we have y-axis or x equals to 0. And we notice that it is continuous. Now let's visualize what happens to the b when it is closer to 0, when it is closer to 1. So this is the case with when it is closer to 0. But when it is closer to 1, lumalayo yan sa x-axis. As b becomes closer to 1. Okay? Now let's have an example. Let's just say we have function f, which is equal to log with base 3 of x. So to solve that, for our domain, we have the 0 to positive infinity. For the range, we have the set of all real numbers. For the intercept, we have 1, 0. Why? We just let x equals to 0. And the only values of x that satisfies that statement is just x equals to 0, x equals to 1 from the property that we've learned a while ago. And it is increasing. The vertical asymptote here is x equals to 0. And it is continuous. After that, we construct the table. In constructing the table, the values of x that you need to have here, it must be multiples of 3 so that you will not use calculator. So, ang strategy lang yan, ang tip lang dito, example, di ba, if this is 1, we are so sure this is equal to 0. Now, I will use 3 here. If I will substitute 3 here as the value of my x. Then, from the property, I got an answer which is 1. So, I have here 3 square, which is 9. I will still use the property. So, if you will have log with base 3 of 3 square, mangyari ay yung exponent ang answer. So, you'll have here 2. And here, you have 1/3 or just 3 to the power of negative 1. So, your answer is negative 1. So, mas easier na siya kung gagamitan mo siya ng mga multiples of 3. So, ito na yung graph niya. So, anong na-observe natin sa graph? As x increases, what happens to y? Y also increases. At ang intercept natin ay 1, 0. Okay? Now, let's have another example. Let's just say we have this case wherein we have our base which is between 0 and 1. So, for our domain, we still have 0 to positive infinity. For our range, we have the set of all real numbers. For our intercept, it is still 1, 0. It is because the value of x that will satisfy the statement is still 1 to make it equal to 0. And it's decreasing, and the vertical asymptote here is at x equals to 0. And of course, it is continuous. So, we have now the table of values. So, we just use here multiples of 1/4. So, you have 1/4, 1/16, 4, 16, so that it would be easier for us to find the value of y. So, this is now our graph, and we notice that it is decreasing. So, kung ma-observe natin that whenever our base here is between 0 and 1, we will produce a decreasing function. Then we have this as our intercept, and we observe that as x increases, what happens to y? Nagdi-decrease ang y. Okay, now let's proceed on graphing transformation of logarithmic function in the form f of x equals to a multiplied by log with base b of x minus c plus d. In this case, we need to learn or remember that our a here, it represents the vertical stretching or shrinking. We need to let a greater than 0 be a constant. So if this a here is greater than 1, then the effect is vertical stretching. If our a here is between 0 and 1, then we have vertical shrinking. Okay, so let's have an example. Sketch the graph of function f which is equal to log with base 3 of x and function g which is equal to 3 log with base 3 of x. We observe that we have a multiplier here which is equal to 3 and it is greater than 1. So what will happen to this? First, let's find its characteristics. So, we observe that it has a domain of 0 to positive infinity from the definition here. The range here is just the set of all real numbers, and the intercept is just 1, 0. Okay, so what we need to do here is we just substitute y equals to 0. Then the only value of x that will satisfy this statement is just x equals to 1. Then for our vertical asymptote, take note that our x here, the 0 must not be, our x here must not be equal to 0 because it will make the function undefined. So for our vertical asymptote, x equals to 0. And it is continuous. After that, we will construct the table. This is now our table. What we use, the value for the values of x, we use the multiples of 3. 3 squared, 3 to the negative 1, and 3 to the negative 2. So that it would be easier for us to find its values. Then, this is now the values of function g also. After that, we will graph the specific functions that we have here. And we notice that function g has a value of 3 here as our multiplier, what happens? Merong vertical stretching na nangyayari. Vertical stretching of 3 units. Diba? Nagsistretch siya. Pero when it comes to intercept, pareho lang sila ng intercept, pareho lang sila ng domain, ng range, pareho lang sila almost lahat. Nagdi-differ lang sila dito na kasi nagsistretch na ang function g kaysa kay function f. Now, let's have another example. Let's just say we have the function g, which is equal to 1/4 multiplied by log with base 3 of x. So we observe that our a here is between 0 and 1. And so our domain is 0 to positive infinity. And our range here is the set of all real numbers. The x-intercept is just 1, 0. It is because if you will let y equals to 0, the only value of x that will satisfy the specific value is just equal to 1. So you have 1, 0. And it is increasing. Why? Because we have here for our base which is greater than 1. And the vertical asymptote is just the y-axis and it is continuous. Then after that, we construct the table and this is now our graph. So what have we observed? This is our parent function, the red one, and the blue one, that is our function with transformations. And we notice that it shrink of 1/4 units. Diba? Nagsishrink ang graph. No? So, shrinking. Merong vertical shrinking na nangyayari sa graph natin because our A here is less than 1, but it is greater than 0. Okay. Now, we will proceed to the value of our C. The value of our C, it represents the horizontal shift. So if our C is greater than 0, here, if this would be x minus C, that means there will be horizontal shift of C units to the right, But if our C here is plus C, you have x plus C. So our C here is less than 0. So you have here, wherein you have a behavior or translation na C units. There will be horizontal shift of C units to the left. So let's have an example. So we have this case. So ang pag-solve ng domain, 0 to positive infinity, yung range ay the set of all real numbers. The x-intercept is just 1, 0, and we have y-axis as the vertical asymptote. In this case, in the function g, what we have here is we have here x plus 2. Since this is x plus 2, then this is what? 1/4. So therefore, we notice since it is 1/4, increasing, decreasing. This means that we have decreasing function. And aside from that, for our domain, the value here must not be equal to 0. So, dapat, ang pinaka-minimum na value, ano yung, so ang gagawin, ang tip lang dito is x plus 2 equals to 0. I-equate mo lang to 0. So, mangyari, ang value ng x ay nagsisimula sa negative 2. Negative 2 plus 2, you'll have 0. So, hindi pwede. Kaya, si negative 2 ay ini-exclude natin. Pero kapag meron kang value dito na negative 2.1 plus negative 1.59. So, mangyari dito, meron tayong mga natitirang values na meron. So, nagsisimula pala siya starting from negative 2 up to positive infinity na yan. So, ang minimum na value, hindi kasali si negative 2 because it will make the function undefined. So, you'll have here for a domain, negative 2 to positive infinity. For the range, we have the set of all real numbers. For the intercept, what we need to do for the intercept here, we need to let y equals to 0. So we have this one. Then for us to get a value equals to 0, the x must be equals to 1. But here we have x plus 2. So what we need to do, we need to equate x plus 2 equals to 1. So the specific value that will make this specific form equals to 1 is just equal to negative 1. So if this is negative 1 plus 1, you'll have positive 1, which satisfies to this, that it will be equal to 0. And we have here, for our vertical asymptote, we have x equals to negative 2, because this will make the function undefined. And of course, it is continuous. Now, we construct the table. After constructing the tables, we notice that ano nangyari? Dahil x plus 2 yan, meron siyang horizontal shift of 2 units to the left. And we observe that it is a decreasing function because our value of our base here is between 0 and 1. Okay, so ito yung basis ng pag-solve ng formula natin. Okay, now let's proceed sa vertical shift. Ang vertical shift, dito tayo nagpo-focus sa D na value. So kapag ang D natin ay greater than 0 yan, that means there will be vertical shift of D units up. Kapag minus D naman to, there will be vertical shift of D units down. Okay, so let's have an example. Let's just say we have function f, which is equal to log with base 3 of x, and function g, which is equal to log with base 3 of x minus 1. So, itong log with base 3 of x, na-solve na natin to kanina. So, we have these characteristics. And for the function g, we are so sure that our x here is from 0 to positive infinity from the definition. The range here is just a set of all real numbers. The intercept is just 3, 0. How do we got this? So, we have here, we let y equals to 0. So, the only value of x that will make this one equal to 1 is just 3 to the power of 1. Because if you have here log with base 3 of 3 to the power of 1, this is just equal to 1. So 1 minus 1, you'll have 0. So therefore, our x here equals to 3 and our y here is 0. So for our vertical asymptote, we have x equals to 0 because it will make the specific function undefined. And it is continuous. Okay, so let's have another example. This is now the table. Now we will construct the tables with its corresponding y values. Then after that, this is now the graph. So kung ma-observe natin, dahil ang D natin ay minus D, so that means there will be vertical shift of 1 unit down. And we observe that our B here is positive 3, so that means it is an increasing functions. So we have here as our observation, the domain of the two graphs is 0 to positive infinity. The range of the two graphs is the set of all real numbers. Note that the base is 3, which is greater than 1. Then both graphs are increasing functions. The x-intercept change. So ano nangyari? Dito, you have 3, 0. Here, you have 1, 0. The graph of y equals to log base 3 of x minus 1 vertically shift 1 unit downwards from y equals log with base 3 of x. The vertical asymptote of the two graphs is the x equals to 0 or just the y-axis. Now let's proceed on the transformation wherein the graph only reflect. So we have reflection about the x-axis. So kapag reflection about the x-axis, we have this form as y equals negative log with base b of x. For reflection about the y-axis, you have y equals log with base b of negative x. So I will show you an example. So for example, we have here function f, which is this one. And function g, na-observe natin sa function g, mayroong negative na nasa labas. So you have negative log with base 1/4 of x. So we already solved this one. So for our domain, we have 0 to positive infinity. For the range, we have the set of all real numbers. For the x-intercept, we have 1, 0. We have here y-axis as the vertical asymptote. And it is continuous. Now, to solve for the function g, we have domain, our values of our x here, still 0 to positive infinity. And we have for the values of y, we have here as the set of all real numbers. And for our x-intercept, what we need to do here is we need to let y equals to 0. So we have this one. What specific value of x that will make this one equal to 0? From the property, we have x equals to 1. So we have here y-axis or x equals to 0 as our vertical asymptote. After that is we need to construct the table. Okay. So this is now the table that we have. So this is for our function f and for our function g, values of y. Then, so we have here as our graph, we notice the red one, this is for our function f. Then we observe that kapag may negative na nasa labas, nagiging reflection na siya along the x-axis. Di ba? Nagre-reflect na siya along the x-axis. Okay? Now let's have another example. What if this would be the case? You have function f, which is just log of with base 1/4 of x. And we have function g, which is equal to log with base 1/4 of negative x. So, nagiging negative x na. So, mangyari niyan, so we need to solve the values or the characteristics. We already done with the log with base 1/4 of x. So, we will proceed sa pag-find ng domain nito. So, sa function g, we have here, ang pwede lang na value ng x natin, di ba hindi man pwede dito na negative na values. So, kaya, ang pwede natin ilagay sa value ng x ay mga negative values. So, you have 0 to negative infinity. Because if you'll have negative 1, for example, negative 1 times negative, you'll have positive 1. Okay? If you'll have negative 2 multiplied by negative, you'll have positive 2. So, it will satisfy to the definition of logarithmic function. So, we have here for our domain, which is 0 to the negative infinity. For our range, we have the set of all real numbers. For the x-intercept, we have negative 1, 0. How do we get that? So, we have here, we let y equals to 0. And the only value of x that will make this specific function equal to 0 is just negative 1. Because if this would be negative 1 times negative, you'll have positive 1. And if this is equal to positive 1, this is equal to 0. So we have for our y-axis, or x equals to 0, is the vertical asymptote here. And it is continuous. Now we construct the table. This is now our table. And this is now our graph. So we observe that our graph here, it is a decreasing function. Decreasing siya because our base here is between 0 and 1. And what we observe with the y equals to log of with base 1/4 of negative x. Itong green na color, ito yung function na mayroong na itong. At itong isa, which is the y equals to log with base 1/4 of x. Na-observe natin that it is just a reflection along the y-axis. Y-axis. Nagre-reflect lang siya. So, for our summary, so we need to remember na kapag ang a natin ay greater than 1, there would be vertical stretching. Kapag ang a is between 0 and 1, you'll have vertical shrinking. So, pag dito naman ay plus c, you'll have here c units to the left. Kapag minus c, you'll have here horizontal shift of c units to the right. And you'll have this form. Kapag minus d, there would be vertical shift of d units down. Kapag dito naman nagiging plus d, you'll have vertical shift of d units up. Pero kapag meron kang form na y equals negative log with base b of x, it reflect about the x-axis. Kapag meron ka namang form na y equals log with base b of negative x, it reflect about the y-axis. So let's describe the transformation of the graph from the parent function. So we have here function s, which is equal to 3 log of x plus 2 plus 1. What have we observed? First, it is increasing because our base here is 10. It vertically stretches. It is because we have here our a is greater than 1. There will be horizontal shift of 2 units to the left, and we have here vertical shift of 1 unit up. For function f, we have 1/2 multiplied by log with base 1/2 of x plus 1. In this case, we have decreasing. It is because our base here is between 0 and 1. We notice that there will be vertical shrinking kasi yung a natin is between 0 and 1, which is equal to 1/2. And we notice that there would be vertical shift of 1 unit up because we have here plus 1. And another is we have this. We have function g, which is equal to ln of x minus 2. So of course, we have here a base here which is e, so therefore it is increasing. And we have here minus 2, so there would be horizontally shift 2 units to the right. I hope you learned a lot for today. So thank you and God bless us all.